A vortex is not an object, not a set object. He says a vortex is just an object. This is subject to the law of resources. Of course, it's quite generic. Isopygian, another part of making a proposition. Isopygian, some things might need to be, say, nailed down. So specifically, in the process before we made some jokes about recognizing permanence, like doing it, not adding a definition or equation for this, recognizes a vortex because it looks like that, and not having an equation for some of those. So I think that is
Oh, yeah. I was going to pass it also to the audience, so I'm not sure.
I'm going to agree with fully. Also, I have to say for consistency, like I said, but I use this conference because this is it. And also because this conference seems like vortex. I mean, truly, vortex is not the line. If I want to line, it's tension, it's just enough. Nobody defines it. Because this is conference seems like vortex is all object. The flow pattern is restricted. And all flow pattern can be repetition. Perfect. And I remember seeing Professor Liu showing a diagram of this consistency. But consistency is high.
Yeah, I mean, if we try to come up with an definition of text that needs some normalized frame, we have a value of one with one text for a value is important. So, I don't think you can necessarily do that, so we maybe have a spectrum of results. Some sort of hybrid, something like that. Set definitions probably.
Yeah.
I can make an attempt.
Sure.
I usually take risks today as well. Perhaps if we want to answer what is a vortex, the definition of a vortex, not yet the analytical definition, doesn't. Perhaps a way forward. First, certainly we would need a rather qualitative description. Rather qualitative. Then, alongside the qualitative description, we could discuss and see if we can identify and agree on necessary conditions for a vortex to occur, period, or insufficient conditions for vortexes to occur. Then we see if we get a large majority, say 75% of the people, then perhaps the brains or the noses, as we used to say, are go in the same direction. Try that. I was thinking, as many of us, a sufficient condition to be that there exists at least one velocity transformation and in one direction chosen, where the local flow streamlines feature a circular pattern. If you have that, then I could say that's a vortex. That would be, it's sufficient for a vortex.
Would a free vortex satisfy?
Huh?
Would a free vortex?
That's right. Let's check. Let's check if anyone thinks a counterexample, that's the best way to kill it or yeah, indeed. So the idea is this is back to the old literature. If you can, vortices can be stationary, but can also be moving in space. So if we say you can find at least a velocity, and at that velocity you find one orientation, because you have to be orientation perpendicular to the axis, and in that orientation you look at the streamlines or the projections of the streamlines, and they feature a circular pattern. To me, I would say, with my hand, that would be a vortex. Huh?
How about it?
No, let's say the feature is a rather circular pattern. Rather.
So I think you mentioned in your talk, so would you consider a recirculation region a vortex or not? And then you raised the question during your talk too.
According to this definition,
Yeah.
then I would withdraw from my talk, and that would be included in the vortex because they are stationary. You choose a plane, and you find the streamlines that have a rather circular pattern. It's very inclusive in these times, it's fashionable. Any counterexample? Any counterexample?
I guess the definition that, what your class is asking. Scott, I'm okay. Well, that's going on with that, and I think it's very good. It includes both rotation and rotation, but it has circulation. Just quite general. Could include all the chronological phenomena in the sea, including all the hurricanes, all the tornado, all the flow is rotation around it.
It'd be interesting to have somebody against that.
Well, I think that this case of having a circular closed particle streamline is quite specialized. So in most cases, you would have a spiral turn, and then this is much more difficult to assess. So if the spiral is expanding from away from the center, then what is the boundary between, or how tight should the spiral be to still be considered as a vortex? Because with spiral, the radius can expand quite quickly. So let's say with a one evolution, If the regulatory content is pipelines, centralized, that's the vertical as a vortex or not.
Yeah, so that's nailing down. So your objection is as follows. You say, if the streamlines do not feature a circular, so to say, closed pattern, instead the pattern happens to be spiraling, what do we say about it? They don't belong to vortices, or can we change the definition to make it even more generic and more inclusive? And including the spirals.
I don't think you can use velocity streamlines to define it. Otherwise, you could just do it that way instead of vorticity.
We are not using vorticity so far. In this moment, we're just thinking about streamlines.
Yeah, the streamlines, just velocity restrictions, right?
Yeah.
If we could just do velocity streamlines as help define the vortex, then we would have done so already. You can't just use stream.
Yeah, sometimes the streamline without, like in my presentation, the result of streamline and the new text, they are different. So for new text, we can see like there are two vertices, but for streamline, we only have one vertices and center is the origin. But I know the formula I put in is I put two vertices. That's my presentation, like a few minutes ago.
That makes sense.
So actually,
Oh, to you, sorry.
definition, but you also test that actually exists, it's 1990 biology. Who actually said, because it's in the review, but also the vortex is when it's embedded two lines mapped on the plane normal to the vortex source, existing the rapidly circular or spiral pattern when viewed from a reference plane moving in the center of the vortex zone. That was the definition of progress back in 1990. Yes, was final. Yeah, we really also the definition of.
Yeah.
Essentially agree with what you said before, but I think what worries are streamlines. I mean, it's not validated environment like the new XCs. And for example, is spiral pattern and clearly top of a vortex, but it's not a closed streamline. So streamline is maybe not the best term to just define a vortex.
Can I say a word? I think we should have two definitions. One is local. Just in the market. So what's just like temperature, pressure, velocity, velocity, they're all defined in one point. So we should say we need give a definition in one point. Well, people usually think vortex is global. So we talk about mathematical definition that is in one point. One point only. Like UV. So we go to clock. That's the vortex one. What is the definition for vortex one? What is vortex one? Vortex one means that at one point. I said, but then we talk about vortex two. What is vortex two? That's the natural vortex, like hurricane, like tornado, like carbon vortex. So we need to, make it clear in the concept. This is two different things. One is at one point. The other one
It's just group the different, variety of vortex. I mean, it was we need separate. It's not the same thing. It's not the same thing. When we talk about this, it's one point. We don't talk about the global version. When we talk about the velocity, it's one point. That's the maximum. The second suggestion, as I said, my opinion, in general, we cannot use streamline because the streamline it is not, currently valid, not objective, not currently valid. So generally, we cannot get a definition is, valid or changed in different coordinates. Suppose not changed in any coordinates, any. Doesn't mean we talk about coordinates means the observer's space. For observer, because what I cannot change. It doesn't mean you use this coordinate to get one, in another coordinate to get two, in the other coordinate to get three. That's not definition. Definition must be any you measure from f from seven, then it must be the same answer. That's important. That's what I said. That's called objective and currently invariant. That's important. Stream, I think they talk is a meeting of people talk. They use the streamline. They use the elasticity. Yeah, well, I can use for engineering, applications. But this is not currently invariant, including elasticity. Elasticity is not, invariant, currently invariant. But we need, make some rules. The rules, you say, if you definition one is one, no matter where, from the earth or from the sun or from the, Mars, same conclusion, one is one. So that's my understanding and my suggestion. Shall I?
Sure.
Yeah, I just disagree to most of it. First of all, we have to be able to listen to each other. When we mentioned streamlines, we didn't just say streamlines. The vortex is anywhere you see streamlines doing a circular pattern. We said something else. We said there must exist a velocity and system of reference, as mentioned here, whereby when you subtract the velocity, you obtain a rather circular, perhaps spiraling pattern. So the Galilean invariance is not violated, it's just involved that you have to do that transformation. Now, I'm afraid we are sliding too rapidly from this definition stage into the analytical description of the vortex. If we go very quickly there, we will forget the definition. And for the experts in the room, we can even go to analytical treatment. But for the world outside, I'm afraid we run the risk of being too cryptic into technicalities. So the idea of a very generic description is really to reach the world outside and have a definition, perhaps already even 50 years ago, where we all say, yes, we agree with that. It's a qualitative definition, maybe based on its manifestation. You mentioned manifestation. We could also define that for us, the vortex, we don't know what vortex is, but we have 5 examples. And these are the pictures. And you teach like this at the primary school. These are the 5 pictures of vortex. And these are some of your intelligence to find out what is in common to this picture. Absolutely. We can, so I think it's, we have to be a bit careful in not going too quickly into the dispute or TCTQ, lambda, mutex, and so on and so forth. Otherwise, the first question will not be answered.
Just following Professor Liu's comment, the way I understand what we are talking about is in limitations that like the derivatives. If it has more for x, it is like when Newton define this derivative is called infinitesimal, right? It's a limitation. The distant approach to zero, what will be the change of the function, right? So in that sense, the way I understand this vortex is infinitesimal vortex. Is your text.
You say it's impossible to get a 1 point.
No, I said if possible, if it is continuous up to the first derivative.
But I think that this is that's the I talked about the one definition at 1 point.
Yes, that's in
mathematics. Yeah, really, in real world, we don't have for fluids. Because fluids, you have, patterns, you have molecular, they not.
So we're not talking about the physics, the real world now is mathematical definition.
Just a way in mathematics, yeah, right. It's not figures. We think that's
But not this definition is the limitation.
yes,
Agree?
yes.
I can differential.
Yeah, different.
Yeah.
Right, that's right.
Yeah.
That's correct.
So that's the way I understand it. Maybe it is the limitation that we call. Like you nail down to 1 point.
Yeah,
That's the way I approach it.
right,
A rotation.
right. Well, that's mathematics. In the physics world, we don't have.
No, it's I know it's a virtual world.
That's
Man, you still
define the two what boundaries is what they can walk at a point. Two is the natural vortex that could be big like, tropic cycling. Every 100 kilometers. Could be small.
I think. I think there's scale. I don't know if this has been tried, but for when we're comparing two vortices, like the local one that's down here and the big one that's in the hurricane, I feel like if you made a hurricane mesh portion, that big swirling thing will be the vortex. It kind of depends on the resolution of the mesh, in my opinion. The higher resolution, the more smaller your vortices are going to be, because it's the local thing. It's based on the points next to it. And then the points next to it are really, really close to it. You're verifying the location is really, really close to that point. But if it's very coarse, then you can evolve what's across the eye of its form as part of the one vortex that exists. And we know that through Dr. Sim Apperson's work and through another work that we did with tornadoes, that big vortices made of infinitesimally small vortices. So it's not just always one big vortex. It's usually
Not that kind of talk here, right? Because
Yeah,
you can really. But just not can see everyone's face here.
Vortex. But yeah, we see it, little tiny dots of micro vortices, vorticing filling. And, those are the vorticing flow to that point. So I feel like defining the mesh in your grid really helps, like the size, scale of the vortices, if that makes sense. Or like big vortices on the sun, you have a bigger mesh, so you can find bigger vortices, you find smaller vortices with finer meshes.
I think all these people, thanks for the sake, can I just take one comment to go back to the rest of our, go on?
Yeah, right.
So our Ronald's comment is, he wants something central to the average person, the street.
Right.
And so coming to find intercepts, and some of these analysis, if you study some of the dynamics, temperature is very powerful. I mean, temperature is sort of a dynamic, has to do with the molecules. But, so when you do it, some of the dynamic, it's trying to find, there's still a temperature